Hi friends, in this video we are going to find the eigen value and eigen vector of this given matrix. So first we have to find the eigen value. So this is matrix is of order 2 cross 2. So first write the characteristics equation of this matrix. So here characteristics equation is here determinant of A minus lambda I which is equal to 0. So here whenever you have 2 cross 2 matrix, here any 2 cross 2 matrix, let's say this is as a node A11, A12, A21 and let's say A22. So the characteristics equation is, that is here the characteristics equation A minus lambda I equal to 0 is same as, this is same as lambda square minus trace of A into lambda plus determinant of A equal to 0. So this is the characteristics equation in lambda. So here what is meant by trace? Trace means trace of this matrix is sum of the diagonal elements, that is A11 plus A22. So here I am using this. This is same as lambda square minus trace of A into lambda plus determinant of this matrix which is equal to 0. So here lambda square minus trace means sum of the principal diagonal elements A11 plus A22 position, that is 5 plus 2. Here trace is given, here trace of this matrix is 5 plus 2. So here directly write, here 5 plus 2 is 7 times lambda plus determinant of this matrix, that is here I will calculate the determinant of this matrix 10 minus 4 which is equal to 6. So this is 6 which is equal to 0. So here lambda square minus trace of A into lambda plus determinant of A equal to 0. Here trace of this matrix is here A11 plus A22 position. A11 position is 5 and A22 position is 2. So this is my trace, that is 5 plus 2 which is equal to 7 and determinant of this matrix is 10 minus 4, that is 6. Now here lambda square minus 7 lambda plus 6 equal to 0. So from here so this is same as, here I will calculate lambda square minus 6 lambda minus lambda plus 6 which is equal to 0. I am finding the root of this quadratic equation. This is same as lambda common, lambda minus 6, here I will take minus 1 as common. So from here lambda minus 6 which is equal to 0. So from here lambda minus 6 and lambda minus 1 which is equal to 0. So this implies lambda equal to, here I will take here directly lambda 1 equal to 6 and here lambda 2 equal to 1. So these are the eigen values of my matrix A. So here now I want to find the eigenvector corresponding to lambda 1 and eigenvector corresponding to lambda 2. Here this is the characteristic equation. Now come to here. So here you know A minus lambda I into x which is equal to 0. I will use this. Here this is the here this is matrix and this is the characteristics vector, or we can say eigenvector. So I want to find the eigenvector corresponding to lambda 1, that is here now I am going to find E minus lambda 1 into I into let's say this is x equal to 0. So this vector, that is after solving this equation, this vector x is the eigenvector corresponding to the eigenvalue lambda 1. So here now we have to prepare the matrix A minus lambda 1 into I into x equal to 0. So here A minus lambda 1 I is, here I will write this A matrix as it is here. Here my A matrix is 5, 4, 1, 2 and here I am preparing A minus lambda I. So here I am preparing A minus lambda 1 I. So I want to prepare first this matrix. Here A minus lambda 1 I, that is this, first I will write this my A matrix this is 5, 4, 1, 2 and this is lambda into I 1, 0, 0, 1. So after writing this is becomes 5 minus lambda. So 5 minus lambda So this is lambda 1 is here. I will put the value of A minus lambda 1 is 6 into I. So here A minus 6 into I. So I will write this matrix into X, which is equal to 0. Here I will write A minus lambda. So for lambda 1 equal to 6. So A minus lambda 1 into I into X, which is equal to 0. I want to solve this homogeneous system of equations for lambda 1. So here after that, just this matrix is here A minus, that is this is same as A minus 6 into I into X, which is equal to 0. Now tell me, so this resultant matrix is, first entry of A matrix is 5 minus 6 is minus 1. So here second entry is 4 minus 0, simply 4. This is 1 minus 1 minus 0, simply 1. This is 2 minus 6, that is minus 4. This is my A minus 6 I matrix. So after that I will write here. So this is lambda 1 equal to 6 and lambda 2 equal to 1 are the eigenvalues of this matrix. Now I want to find the eigenvector corresponding to lambda 1 equal to 6 and eigenvector corresponding to lambda 2 equal to 1. So here I want two eigenvectors. One is corresponding to lambda 1 and one is corresponding to lambda 2. So here, so first I will build matrix for lambda 1 equal to 6. Now I will find the eigenvector corresponding to the eigenvalue lambda 1 equal to 6. So for that I want to so that means I want to solve this A minus lambda 1 into I into X, which is equal to 0. So here, so before that, so maybe some of don't know, here this is means A minus lambda 1 is 6 into I into X, which is equal to 0. So here A minus 6 I matrix means, first write the A matrix. Here I will write the A matrix. Here 5 4 1 2. So after that minus 6 times I. This is 1 0 0 1. So here whole bracket, here I will take, this is X, which is equal to 0. So here now this is same as here 5 minus 5 4 1 2. So here this is, here just multiply 6 0 0 6 into whole bracket, so X, which is equal to 0. Now this means just subtraction of these two matrices. Here I will write here 5 minus 6 minus 1, 4 minus 0 4, 1 minus 0 1, 2 minus 6 minus 4 and X, which is equal to 0. So here this is the matrix. So therefore A minus lambda 1 into I into X, which is equal to 0. So this is same as, so here this is same as A minus lambda 1 is 6 into I into X, which is equal to 0. So here this means, here I will write this matrix directly. Here A minus 6I, this A minus 6I matrix is minus 1 4 1 minus 4, and here I will write this as x1 and x2, which is equal to, let's say here I am writing x and x1 x2, which is equal to, here I am writing 0 and 0. Now this is my homogeneous system of equation. Now two equations, two unknown. Now so after that I want to convert this matrix into the echelon form. So here I want to convert this matrix, let's say, into the echelon form. So here, so this is my matrix. Here I will take, here I am applying the elementary operation as, and first I will flip the rows, or otherwise I will multiply minus 1 to the row R1. So after that this matrix becomes here 1 minus 4. So this is 1 and minus 4 as it is. So after that I want to make this one as 0. So here I am applying the operation. R2 changes to R2 minus R1. So here this matrix becomes, first way as it is 1 minus 4. So here 0, here minus plus, this is simply 0. So here now this matrix is into the echelon form. So again back substitution. So here that is 1 minus 4 0 0 into this matrix. So let x1 x2 which is equal to here 0 0. Now so this matrix. Now again use the back substitution. So what will happen? This is same as x1 minus 4 x2 which is equal to 0, and here now here rank of this matrix is 1 and number of unknowns are 2. So I want to adjust one. I want to assign one free parameter either to x1 or x2. But here corresponding to x1 I have pivot in my first column, but corresponding to x2 I don't have pivot in my second column. So that's why here I am assigning x2 as t. So let x2 equal to 2. Therefore x1 equal to 4 times, that is x2 is t, which is equal to 4 times t. Therefore my vector here x1 comma x2 which is equal to, here x1 is 4t and x2 is t. So this is same as, so here I will take t as common. So here 4 comma 1. So this is same as t times x1. This x1 vector is the eigen vector corresponding to the eigen value lambda 1 equal to 6. Therefore this is eigen vector corresponding to eigen value lambda 1 equal to 6. So this is my one eigen vector. So this is my one eigen vector corresponding to the eigen value lambda 1 equal to 6. Now in the same way I want to find the eigen vector corresponding to lambda 2 equal to 1. So here same. So I don't have space, that's why I will remove this here. So I will solve here the same thing. Now so for lambda 2 equal to 1. So for lambda 2 equal to 1, so this matrix becomes A minus lambda 2 into I into x equal to 0. This is same as here A minus lambda 2 is 1. That is 1 into I, same I into x which is equal to 0. So again I will write this same matrix here. So you know how to write A minus I, just subtraction. Here first position of this matrix is 1 and first position of identity matrix. So first position of this matrix is 5 and first position of this matrix is 1. So 5 minus 1, that is 4. This is A12 position of this matrix is 4 and the A12 position is 0. So this is simply 4. Now come to here. This is 1 and second A21 position of this identity matrix is 0. Simply here 1. And this is 2 and the A22 position of this identity matrix is 1. So this is 2 minus 1 is 1. Now here I will write this x as again x2. So again I will write this as 0 and 0. Now again I want to convert this matrix into the echelon form. So here I will write here. Here I want to convert this matrix into the echelon form. Here this is my matrix. Here 4 4 1 1. So here I will apply the elementary operation. That is I will divide 1 by 4 to the entire row R1. So here I got the matrix as 1 1. This is 1 1. So after that I will here again I will apply the elementary operation as here R2 changes to R2 minus R1. So here I got the matrix as this is 1 and 1. This is 1 minus 1 0. This is 0. So now this matrix is into the echelon form. So here write this here 1 1 0 0 and this is simply x1 and x2 and this is 0 0. Now here rank of this matrix is 1 and number of unknowns are 2. So I want to assign one free parameter to either x1 or x2. But here corresponding to x1 I have a pivot in my first column, but corresponding to x2 I don't have pivot in column 2. So here I am assigning, that is back substitution, x1 plus x2 equal to 0. Here I am assigning x2 as x2 equal to, let's say, t. So here that is therefore x1 equal to minus t. Therefore here x1 x2 which is equal to, here x1 is minus t and x2 is t. So I will take t as common. So this is minus 1 1. This is same as t times x2. So this is the eigenvector corresponding to the eigenvalue lambda 2 equal to 1. Therefore this is eigenvector corresponding to eigenvalue lambda 2 equal to 1. So here this is the problem. Here this is my matrix A of order 2 cross 2. So first find the eigenvalue of this matrix by using this characteristic equation A minus lambda equal to 0. If this matrix is of order 2, so this is the direct characteristic equation lambda square minus trace of A into lambda plus determinant of A equal to 0. Trace means sum of the principal diagonal integers of this matrix. Here A11 plus A22, that is 5 plus 2 is 7. 7 into lambda plus determinant of this matrix is 2. Here 10 minus 4, that is 6 equal to 0. Just find the root of this quadratic equation in terms of lambda 1 lambda 2. Lambda 1 equal to 6 and lambda 2 equal to 1 is the root of this equation. So lambda 1 equal to 6 and lambda 2 equal to 1 is the eigenvalue of this matrix A. So two eigenvalue. Now corresponding to lambda 1 equal to 6, now we have find one eigenvector, and corresponding to lambda 2 equal to 1, now we have find the another eigenvector. So this is the way to find the eigenvalue and eigenvector of the given problem. Thank you.